Hi, this is Dr. John Bergduff. In this video, I want to talk about subtracting integers on the number line and how that can be illustrated. And actually, if you check the literature, you'll see that there are a bunch of different ways that different teachers show subtracting integers on the number line. So I encourage you to watch a number of videos and read a number of books because you'll see some different approaches and find the one that works best for you. The approach I'm going to use is going to focus on the missing addend definition of subtraction. So I want to start by talking about what I mean by that and illustrate a very simple example on a number line, and then we'll build from that and eventually come up with a rule or procedure or theorem that says how you go about subtracting two integers. Let's start with something very simple. 4 minus 3. When you're subtracting numbers, the two numbers that you're subtracting have names, which are probably nice to know at some point. The number you are subtracting from is called the minuend. The number you're subtracting is called the subtrahend. And I apologize for my sloppy writing. What you get when you do the subtraction, which I'm going to leave this suspenseful for a minute, what 4 minus 3 is, the result that you get is called the difference. Not enough room. Let me try that again. The difference. Now, the way the missing addend definition of subtraction works is if you want to figure out what is 4 minus 3, minuend minus subtrahend, you ask yourself, what do you need to add to the subtrahend to result in the minuend? What do you need to add to the second number to give you the first number? Now, this one's pretty easy. I can see just by looking at it that I can fill in the blank with a 1, and that tells me that 4 minus 3 is equal to 1. Now, how does that translate to a number line? Well, let's draw a number line. And we're mainly going to need positive numbers for this example, so I will stay over here in the positive direction. And I still want to illustrate 4 minus 3 is equal to 1. But I want to do this in the missing addend approach. 3 plus what number would give me 4? When we talked about addition on the number line, we remembered that we always start at 0. And my first number, which would be that subtrahend, is a 3, which represents an arrow that begins at 0 and moves 3 units to the right. The question I am looking for then is what arrow would I have to add to that so that I end up at 4? And I think you can see pretty clearly that the arrow you would have to add, one more unit to the right. So 3 plus 1 is equal to 4, or more definitely 4 minus 3 is equal to 1. Let's see what that would look like if we had some negative numbers involved. What if we had 2 minus 3? Okay, well, we can't do that with sort of our really elementary ideas of subtraction because we are subtracting a larger number from a smaller. But if we look at the missing addend approach and we look at a number line, we'll be able to figure this out. 2 minus 3 is equal to what? In other words, what do you add to the subtrahend? What do you add to the subtrahend to get the minuend? What do you have to add to the second number to get the first number? Let's do that with a number line because it'll be much clearer that way if this is not obvious to begin with. So let's put some negatives in here this time just for fun. Now my first number is a 3. That's my subtrahend, and that represents an arrow 3 to the right. I want to add another arrow to that. What do I add to that so that I end up at 2? Well, I want to end up here at 2. So if I'm at 3 and I want to end up at 2, I would have to draw an arrow that goes 1 unit to the left, and that would be -1. 3 plus -1 is equal to 2, or 2 minus 3 is -1. Let's try another one. Let's look at -3 minus 2. What is that equal to? Well, what do we add to the subtrahend in order to get the minuend? What is the missing add-in? So here we would start with an arrow that represents 2, and we would think about what arrow do I need to add to that in order to end up at -3. Excuse me. My number line is not very pretty. Let me try to make that better. All right, that's pretty okay. So, starting with the 2, it's an arrow that begins at 0 and ends at 2. And then I want to think about where I want to end up. I want to end up at -3, way down here. What arrow would I have to add to the arrow I've already written in red to end up at -3? Well, to get all the way down there, I'd have to start here and go all the way back here. And that's 1, 2, 3, 4, 5, -5. 5 units to the left. So 2 plus -5 is -3, which means -3 minus 2 is -5. Now, obviously, we're going to look for some shortcuts in here. So hang on to these answers, and we're going to see what happens in a few minutes. Let's add another page. Here's a different one. 4 minus -2. My subtrahend is negative this time. But let's not let that bother us. We're going to be asking ourselves, what do I need to add to the subtrahend? So I'm subtracting a -2. I'm starting with a -2. What do I need to add to the -2 to get the minuend of 4? Let's draw our number line and see if we can figure that out. -2, -1, 0, 1, 2, 3, 4. We start with an arrow representing -2. All arrows start at 0 to the left. So -2. And then I need to end up at 4. So I need to ask myself, what arrow do I need to add to -2 to end up at 4? It would have to go from here all the way over here. And that's 1, 2, 3, 4, 5, 6 units to the right. -2 plus 6 would equal 4. So 4 minus -2 is 6. I want to think about, imagine in your heads a different mathematics problem that would give you the same answer. I bet you can come up with one pretty easily. One more example, and then we'll be satisfied for now, and see if we can come up with some patterns. -3 minus -3. What's that equal to? So we would be taking my subtrahend and asking, what do I need to add to that to get the minuend? Here's my number line. -3, -2, -1, 0, 1, 2. My first arrow is a -3. Start at 0, go 3 to the left. What would I need to add to end up at -3? Oh, I'm already there. I'm already there. I don't have to add anything at all. This would be a 0. So negative 3 minus negative 3 is 0. Now let's see if we can see some patterns in here that would be useful to us. I am going to need to create a little clean space here. But what I want to do is I want to observe the answers to the questions we've had and notice that what we have illustrated can also result in some simpler results. Going back to addition. So here are the examples we looked at. 4 minus 3 turned out to be 1. 2 minus 3 turned out to be negative 1. Negative 3 minus 2 was negative 5. 4 minus negative 2 turned out to be 6. Negative 3 minus negative 3 turned out to be 0. Those are the 5 examples we did. I want to compare this with some addition problems that we might have learned about when we looked at adding integers. What's 4 plus negative 3? Well, when you add two numbers with the opposite sign, you subtract the absolute values of the two numbers and give the answer the sign of the number that's larger in absolute value. 4 minus 3 is 1, and the number largest in absolute value is 1. Look at 2 plus negative 3. 2 plus negative 3, the number that's larger in absolute value is negative. This would be negative 1. Look at negative 3 plus negative 2. You see what's going on here? It looks like a subtraction will give me the same answer as adding the opposite. 4 minus 3 is the same as 4 plus negative 3. Let's keep going and see if that's true. Negative 3 minus 2, is that the same as negative 3 plus negative 2? Yeah, when two numbers have the same sign, you add the absolute values and give the answer the common sign. Adding the opposite here, the opposite of negative 2 is positive 2. Subtracting a negative 2, I think we're going to find out is the same as adding a positive 2. What is 4 plus 2? Oh, that's 6. Okay. Negative 3 minus negative 3, let's compare that to negative 3 plus 3. Adding the opposite, that would give you 0. The point of all this is that using the number line, we can demonstrate a property that is sometimes just stated as like a gospel truth that came down from heaven, but there's actually a way to illustrate it. Subtracting integers. To subtract two integers, add the first to the opposite of the second. That's a rule we all know and love, but the number lines give us a way to illustrate that. Let's do two more examples and just make sure we feel comfortable with that. Negative 5 minus 4. For subtracting two integers, we add the first to the opposite of the second. The second, or the subtrahend, right now is 4. We're subtracting 4. Subtracting 4 is the same as adding negative 4. Negative 5 plus negative 4 is negative 9. Negative 3 minus negative 6. The subtrahend is negative. If you're subtracting a negative, it's the same as adding the opposite, so adding a positive according to this rule. Negative 3 plus 6. And by our rules of addition, that should give me a positive 3. So I hope this illustration with number lines helps you see maybe a way that you could explain to others how the rules for subtracting integers work. Thanks.